Hello, everyone. Welcome to the Internet of Senses podcast. My name is Tyler Heaton. I am a sound designer and researcher in the Spatial Technologies Applied Research and Training Center at Lethbridge College, where I specialize in the implementation of spatial media and technology in immersive experience design. The Internet of Senses podcast is a series of podcasts with experts in various fields that focus on our five senses. The Hearing series is an opportunity to explore how we process auditory signals and the amazing research and technology that is being developed in the world of sound and hearing. Today, we are joined by Dr. Julia Campbell to talk about auditory processing, brain plasticity, and the neuroscience of hearing. Julia Campbell obtained a clinical doctorate of audiology and triple research doctorate in speech, language, and hearing sciences, cognitive neuroscience, and behavioral neuroscience from the University of Colorado at Boulder. Currently, she is a clinical associate professor in the Department of Speech, Language, and Hearing Science at the University of Texas at Austin, where she serves as the audiology program director and principal investigator of the Central Sensory Processes Laboratory. Julia also serves as the chair of the Scientific Advisory Board for the Misophonia Research Foundation. Julia's research interests are focused on the identification of an objective measure of tinnitus using EEG, and she has published on this and related topics in the American Journal of Audiology, Journal of Speech, Language, and Hearing Research, and the Journal of American Academy of Audiology, among others. Julia, thank you for joining us today.
Pleasure.
So I've been really excited for this one to talk about neuroscience as it relates to hearing and audio processing. This is, a really science-heavy topic, and I say science-heavy in a good way. I think that it's really great for us to understand that science of hearing and audio processing and how that works. And we'll use that as a bit of a jumping off point for the conversation today. So to set some groundwork and provide some groundwork for our audience, can you give us a brief explanation of auditory processing in the brain? Kind of like the cocktail party overview of how hearing and audio processing works.
Sure. I guess I would start at the beginning, and that's the fact that all sound are pressure waves through the atmosphere, and those pressure waves reach your eardrum or your tympanic membrane, and that causes your tympanic membrane to move. And then that in turn causes your ossicles or the bones in your middle ear space to vibrate in a very complex manner. And that then causes fluid movement in the cochlea or the inner part of the ear, which sets off a cascade of neurotransmitters and eventually action potentials that activate the eighth nerve, the hearing nerve. And that nerve then connects to the brainstem and goes through several hubs in the brainstem up through the thalamus, which is known as the gatekeeper to the cortex part of the brain, which is the highest centers of processing in the brain. And so then sound reaches your primary auditory cortex, which is the first stop in the cortex. And from there, connects to secondary auditory cortex, frontal cortex, prefrontal, all different areas throughout the brain. It's best to think of it as a network, like a motherboard, rather than this area is dedicated to auditory processing, because there's a lot of interaction, as we'll talk about later, with different sensory systems as well throughout these areas. And so that's how sound gets to the brain. It's really an interaction between excitation of the nervous system, but also inhibition. And inhibition or suppression of neural activity is really how our central nervous system works. It fine-tunes excitatory activation. It provides a balance to the nervous system and the different firing rates and synchronies that we see. And so this interaction, again, we'll probably talk about it later, but it's very key to having a balanced nervous system and being able to process sound accurately. And probably the last general thing I'd say about auditory processing is it's very temporally regulated. And so that means timing. we're very, very tuned, I would say exquisitely, to the timing, and that's how we process sound. Whereas, to kind of give a contrast, the visual system is very spatial, very 3D, location oriented. And so, again, these two systems are heavily intertwined to be complementary to one another.
That's very interesting. I'm glad that you mentioned the timing side or the temporal nature of sound, because I think a lot
Mhm.
of people we don't think about that, but it's
Right.
quite an interesting part when you start looking at things like ILD and that kind of
Hmm.
stuff. And well,
Hmm.
I guess not ILD, but ITD.
Right.
Uh,
Both of those.
yeah,
Yes.
both of those, and how they relate to localization, which is
Hmm.
uh, sort of one of my areas of research.
Hmm.
Um,